Hi, my name is Joey Cayley, coming to you live from Quarantine 2020. This is April in Ohio, and I'm currently finishing up my prototype project for Ohio State's Mechanical Engineering 2900 course, Intro to Mechanical Design. So this course has two parts to it. The first part is a machining section in which you learn about machining and construct this piston, which is tolerance to 1/1000th of an inch, makes a cool little poppy noise. And then the second part, which is the section I'm in currently, is a electromechanical or mechatronic section where you learn about the electrical side of controlling and moving mechanical systems. So for this, you have to build a prototype as your final project. And for that, I constructed a two-part prototype, one, a flight computer, and a rocket model motor test stand. I shall go into both in this video and kind of describe them and showcase how they work. So this is right here is the flight computer. There are basically three components, starting with this piezo buzzer here. This would be used to help communicate with the user through the side of the rocket. So if there was like a Bluetooth module installed, you could drop this into the rocket and then use sounds emitted by this to help indicate when you set up certain functions, when it's getting ready to start recording data, etc., etc. This right here is the main brain of it. This is the accelerometer, gyrometer, and main temperature sensor. It's all computed into this MPU 6050 chip. Super nice little feature. There's a lot of work for the I2Z on that. And then finally we have this humidity and temperature sensor. It's not great, it only records data every 2 seconds, but it's useful and helps kind of supplement this data, and also would be useful as it goes up to help just kind of provide humidity, see how that changes over the course of the flight. If we'd like to see it in action, I can just reset it. The code's already uploaded. We hear the sound effect start, and I can start moving it. Data will start appearing on the screen. So now this data is nice, but it's kind of difficult to read, so I can just basically Control-C that, and go into this little text file I've created, Control-V that data, save it, and then I have written a MATLAB function that can then proceed to graph that data. So we got acceleration, velocity, and position graphs based on that. This is for the X direction. So this right here is the model rocket motor test stand. It can be broken down into 4 parts, starting with here, the actual test stand where the motor sits and the load cell measures its thrust, which is connected to right here, the data interpretation, which interprets the current running from this and turns it back into force values, which it sends to the Arduino. And then we have the ignition system, which ignites using a 9-volt and a relay. It's able to ignite these igniters and provide enough current to ignite a rocket motor. And finally, the LCD screen and the user interface button. So this will serve as a basic demonstration of the system before the full launch. So we upload. Check the screen. As you can see, it's going to show the title, the Thrusty Measury Boy 2000. And it gets to check the serial monitor, so we go to that. So we started the tearing sequence, so make sure that all weight is removed from it. And then we tear it by clicking the button. And see the tear finishes, and then we calibrate it. So the calibration procedure is you put a known weight on top, this 5-pound weight. And once you're ready, you press continue. That's calibrating. Now read the weight. It's currently right about the correct one because I already calibrated earlier. 22 pounds, it sits newtons, 22.24 newtons for the 5 pounds. This calibration factor, as you get it more negative, it will bring down this reading. As you make it more positive, it will increase this reading. It basically acts as like a scale factor. But there's a lot to go into that, but I will just kind of briefly glance over that. But now it's calibrated. I just click the button again to end it. All right, so now it returns the screen. So here, now if we run actual launch, which we'll do outside, we put the motor in, we get everything set up here, and we just get ready to fire it. So in this case, I'm just gonna fire it because it's no igniters in there. But we press to ignite, firing in 3, 2, 1, the relay clicks, and now we're receiving data. So you see that's the force measure being measured along with how long it's been since the ignition started. And that's basically how the system works. This has all been calibrated and just waiting to fire now. I see, finished up calibration. Now we're just gonna press it. A little hard to see, I apologize. So. Yeah, she ain't working. Since the launch was a failure, I thought I'd just go into a little more detail since we won't be able to see the launch data. We're back at that ignition screen. We click ignite, firing 3, 2, 1. Hear the relay click. Now if we look, we're receiving data. As you can see, I just want to show you as I apply force, it will change the readings. So it truly is receiving data, and it's receiving good quality data in newtons. So yeah, that kind of sucked that the launch failed. I really would have liked to have seen the data and liked to have seen the actual launch. However, I tested the circuit with a DC motor, which I'll show here. As you can see, the circuit works fine. There just appears to be some issue with the motor or the igniter. Maybe I need a new battery. I couldn't quite tell you. That still required some more troubleshooting. However, it appears that everything I have built and designed functions as intended. It's just some small component isn't quite up to spec, and so I still need to go back. I'm going to have to go back and troubleshoot that, but the circuit as a whole largely is functioning. But at the end of the day, failures are a part of engineering. You have to, when you're creating something new, you have to know that you're going to mess up a lot. You have to understand that and be willing to go through that. But it's through those failures that you learn. Like last night, I was finishing up the circuit, and for some reason, I just kept getting bad values from the load cell. I couldn't figure out why. It worked the day before. It was working fine. I just swapped the wires this morning, swapped them in a new port, and it worked beautifully. I couldn't tell you quite why, but I will have to troubleshoot that for future examples. And sometimes that's just what happens. You find something wrong, you just need to take a step away, come back to it later, and figure it out again. And you can persevere through it. It just may take some time and effort, and it might not work the first time.